Hello everyone, we are Team Shredzilla, and this semester we have created a biomass shredder for our MEGN 301 course.
The operation is simple. Turn the machine on, load the hopper, and press down with the wooden press bar to discourage any blockages or clogs.
Biomass is referring to matter from deceased organisms, which includes things such as twigs or bad and leftover crops. Biomass is an important resource for promoting sustainable energy because it can be burned for fuel. Also, underdeveloped countries who don't have the energy infrastructures that we do in the United States are more reliant on biomass fuel sources. A critical first step in the process is size reduction into small particles, which is the job of our biomass shredder. The shredder accomplishes this with a limited amount of labor involved, and it overall prepares biomass to be briquetted later on.
Constraints for design. We have a budget of $230 maximum, and we also need it portable, enough for one person to lift and carry, but also for us to fit on our storage shelf. It also needs to be compliant with OSHA machine guarding guidelines. Now, for instance, you could look at our hopper. We had to leave a maximum 1.5 inch slot so that you can't really stick your whole hand in there. Our design also needs to use a 1/3 horsepower motor and receive power from an outlet at 120 volts AC at 15 amps.
Additionally, the shredder had to meet multiple objectives. We had to finalize a working prototype by April 29th. The prototype has to be able to handle a consistent input flow and output flow of material. The material can't be bigger than 1/4 inch. Anything bigger might increase the chances of component failure or blockage. And the biomass shredder has to reduce these particles at a reasonable rate.
Our final shredder design utilizes a 1/3 horsepower motor to spin a flywheel system and shredder drum at approximately 550 to 600 RPMs, which we verified by measurement. This produces approximately 22 foot-pounds of motor torque, which is capable of shredding common biomass in Colorado. This shredder design is also OSHA compliant for safety and user protection.
The mechanisms are simple. A 1/3 horsepower motor attached to a coupling spins a pulley attached to a flywheel via belt. This pulley assembly spins a shaft with 6 integrated teeth. As these teeth rotate, they break down the wooden particles into smaller particles.
At the beginning of this project, we came up with 4 design metrics as a group. And now this is the comparison of how our prototype held up in testing to these design metrics. The first metric was that it can shred 1/4 inch sticks, and it does do this. The second metric was that small items can be shredded, such as peanut shells and leaves, and it does, for the most part, shred smaller items. However, a lot of them can get stuck or go right through the slots. The third metric was that the shredder can shred at a consistent rate, and this is true. However, the rate of shredding is reduced because we need a push stick to encourage mass flow and get the blades to bite more into the material. The fourth and final metric was that the system runs at 550 RPM from the required 1/3 horsepower motor, and this is true. Our system operates at 543 RPM, which is very close to 550 and meets our goal and allows for material to be shredded.
Last but not least, I want to highlight several opportunities for future improvements that can enhance both our performance and manufacturability of our shredder. First, we plan to apply CSM principles. One of our key goals is to reduce welding on the frame and shift toward a bolt-together design. This will simplify assembly, improve consistency, and make future repairs or modifications much easier. Additionally, we want to implement a better feed system. While the current version is functional, improving its design could lead to a smoother and more reliable operation. We're also working to implement interchangeable parts. This is particularly important for components like the blades, which will wear out over time. Another goal is to manufacture with precision techniques. If budget were not a concern, or even slightly increased, we would use milled or CNC machine components for tighter tolerances and improved fit. Improvement is an ongoing step. These proposed updates reflect what we've learned through prototyping and testing, and they point toward a more refined, reliable product for the customer going forward.